Alright, it's another year, 7th grade. So start off what should be a review from last year, a little bit terminating repeating decimals. This basic idea here is any decimal falls into one of these two categories. So terminating is anything that ends. It's like the number 0.12 or 0.23 or 0.487. Anything that comes to an end, you say is terminating. On the other side are repeating decimals, which are decimals that never end. It's like if you had 0.333 forever, right? That's repeating. So you would call that just 0.3 with the bar above it. And so anything that looks like this, so if we had 0.12 with a bar over it, that would be 0.1212 forever, right? Or you can get a little bit fancy if you had something that didn't repeat all the time. So let's say 0.83333. So in this case, the only number that's repeating is the 3. So we would write that as 0.83, but then the bar would only go above that 3. All right, so there's your basic idea. Terminating ends, repeating does not. So if that was it, this would be easy because you could probably tell the difference between numbers that have bars above them and numbers that don't. So the real test here, and what they want you to do in 7th grade, is not so much be able to identify terminating and repeating, is to be able to take fractions and just turn them into decimals. So really what this comes down to, even though it's called terminating and repeating decimals, it's just turning fractions to decimals. So 2 ways we can do this. This first set here is a little bit easier, and that's to go back and think about how place values work. So if we were to take a number, 1, 2, 3, 4, okay? And we know this first place value to the right of the decimal, that is our tenths place, right? The next one after that is the hundredths place. And then going on, thousandths, and you get the idea, 10 thousandths, 100 thousandths, so on and so on. So if you can get a fraction that is written in a way that you can read it using one of those numbers, like 3/10 is literally just 3/10, where 3 is in the tenths place. Okay, and that's it. So if we look at B here, it's a little bit different because there's no 25th place. So you think, could we rewrite this fraction as something with a denominator that's one of these numbers? And hopefully you can recognize that 3 over 25 will be equal to some number over 100. Because 25 is a quarter, and some number of quarters makes 100 cents. So how do we do that? So 25 times 4 equals 100. So we can do the same thing on top. So 3 times 4, well, that's 12. So what we're left with is this number 12 hundredths, which is literally 12 hundredths. And that's it. So anytime you want to go from decimal to a fraction, you literally just read that number. Okay, not too bad. So our third one, C here, -6.5. So really we're only worried about the decimal part. This whole number is not going to change. So we know part of our answer is going to be -6 point something. So we just have to figure out what that point something is. So if we take 1/2, and hopefully at this point in your life, you're aware of what 1/2 is as a decimal. But if not, that's okay. We can do our little trick here. How can we make 2 end up as a denominator that's one of these numbers, tenths, hundredths, thousands, so on? So I would say the easiest one would be, I know 2 times something equals 10, and that something happens to be 5. So 2 times 5 is 10. Do the same thing on top. So 1 times 5 is 5. Let me change my color back. So 5/10. So it's literally just -6.5, or -6 and 5/10, which is -6.5. So all of these here, these would all be considered terminating. There's nothing repeating here. So anytime you can do this trick, it's not really a trick, it's just math, where you can rewrite the fraction as something over some power of 10, which is what these are, 10, 100, 1,000, powers of 10, it will always terminate. always, 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 most of the time. In 7th grade, always. Okay, that's the easy ones, if you can recognize it. The other way, everyone's old favorite. How do we change a fraction to a decimal that's not something easy to work with? 4 magical letters. T-I-B-O, or top in, bottom out. Which basically just means take your top number, whatever it is. It's not a very good arrow. It's okay. 7. Put that inside our division house. Bottom number goes outside. So how many times can 8 go into 7? Well, this is a proper fraction. That answer is always going to be 0. So what do? We add a decimal, and we add a couple zeros. So we say, how many times can 8 go into 70? Well, I know 8 times 8 is 64, so this has to be 8. This gives us 64 here. 70 minus 64 is 6. Bring down our 0. How many times can 8 go into 60? We just start the process over. That's 7. 7 times 8 is 56. Let's see, subtract. 60 minus 56 is 4. Still going here. Bring down another 0. How many times can 8 go into 40? It's 5. 5 times 8 is 40. And we have a 0 here, which means there's nothing left to divide, which means our division has terminated, which means this is our answer, and we have a terminating decimal. So we have 0.875, but then just so we don't make any mistakes, lose a couple points, this started as a negative, so it has to be negative 0.875. And that's it. So really what this comes down to is, can you divide numbers? And if that answer is no, then you need to go back to your multiplication chart and go learn your multiplication chart, because that will be how you learn how to divide. No way around. All right, our next one. Now let's skip this one. Let's go to F. So negative 3/11. Same idea. Top number goes inside. Bottom number goes outside. Can 11 go into 3? No, it cannot. So we had a decimal, a couple of zeros. 11 goes into 30. 2 times. 2 times 11 is 22. Gives us 8. Bring down the 0. 11 goes into 80. 7 times. 7 times 11 is 77. So that gives us 3. And a 0. And then you would say, how many times can 11 go into 30? And then you think, wait a minute, I've been here before. That's where we started. So we know 11 went into 30 2 times. 2 times 11 was 22. So we say 8, and then if we bring down a 0, just for the fun of it, how many times does 11 go into 80? So wait a minute, we've done this before. I know that's going to be 7, and then I know the next number is going to end up being 30, and this is just going to repeat. It's going to go on and on. We can divide for the rest of time, and we'll always just get 0.272727. So that's it. We stop. We don't have to keep going. Once we see that it's going to repeat, we're essentially done. So our answer, we keep the decimal part, 0.27, not the, oh, okay, hold on, let me go back. Excuse me. 0.27. I still can't draw. Good 2 here, whatever. So put a bar above this. That was negative, so we keep it negative. That's it. That's our answer. And we'd say this is a repeating decimal. Okay, so letter E, 2 and 1/8. So same as before. If it's a mixed number, if you start off with a whole number, you say, okay, great. I know part of my answer is going to be 2 point whatever 1/8 is. So all we got to do is come down and we just divide 1 into 8. So again, same thing, proper fraction. 8 can't go into 1. So we add a couple of zeros. I did this one with 8s and I needed 3 zeros, so I'm going to assume I'm going to need 3 zeros for this one too, because I've done this before. 8 will go into 10 just once. It gives me 8. Subtract, get 2. 8 goes into 20 twice. 16. 20 minus 16 is 4. 8 into 40 is 5. 5 times 8 is 40. We have nothing left over. So if that's the case, we're all done. So we have our whole number in front of it. So 2.125 terminating. That's done. That's it. All right. Our last one. Let's pick a different color. Let's go purple. 8 1/3. So again, since it's a mixed number, 8 point whatever 1/3 is. Which again, 1/3 pretty common. Hopefully you know 1/3. If not, you'll know in a couple seconds here. 1 goes in, 3 goes out. Gonna give ourselves, we'll say 3 goes into 1 0 times. Add a couple zeros. 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. Bring the 0 down. And then get this situation again where how many times can 3 go into 10 is what we just did. So we know that next number is going to be 3. And the number after that is going to be 3. And the number after that is going to be 3. And then we divide for the rest of the time, and it just keeps being 3. So since we don't want to divide for the rest of the time, we just take one of those 3's, put the repeating bar over it, and forget the rest of this ever happened. Okay, so our answer, 8 1/3, would be 8 point, oh, that's not the color I wanted. 8.3 repeating. There you go. Terminating and repeating decimals. Go practice your dividing. All right, good night.